Malban here, and I wanted to show you how to get the virtual machine running to develop for PiTrex. First of all, you have to download the file, the virtual machine state. The link will be on my page. Then I power up VirtualBox. It looks something like that. Never mind that I already have a virtual machine here. What you have to do is to import the new virtual machine, and you do that with appliance import. This is German, but there will be some, whatever it's in English, but import. So then you choose from your local file system the file you want to actually import. Wherever you downloaded it, it's called PiTrex Baremetal Dev Ubuntu 16.01.07 OVA. This OVA is a file format which is an open virtual machine appliance. You can open or import that with Oracle VirtualBox, and I think with VMware you can import it too. I haven't actually tried to import it with Parallels. Perhaps that works too. I don't know. Anyway, you go there and, well, just leave all these settings as they are, or you can of course change wherever your virtual machines should reside. Then you click import, and then, well, it takes about a quarter of an hour, half an hour, something like that. It's well, quite some processing to be done, and after you are finished, VirtualBox will look something like that. Then you have this virtual machine, which is for the first time switched off. You can switch it on, which is what I'm doing now. This should be exactly the same as you will see. It's booting up. The file, by the way, is about 4 gigabytes. I actually don't know why it is so large. The original virtual machine I downloaded was about 2 gigabytes. And then I installed about 200 megabytes, and now it's 4 gigabytes. I can't explain that. I don't know. Okay, here the virtual machine is running. Don't worry, the window will get larger soon. The default user is Ubuntu, and the password is Ubuntu 2 with a non-capital U in the beginning, so all small letters. You can log in. Now the screen gets bigger. You wait a few seconds, and Ubuntu Linux boots up. So this is the virtual machine as you see it when it first starts. I usually like to work with some sort of file manager. If you're a crack into a command line, you can do that too, but for me, I always use some kind of commander, and I installed already here something called Crusader. You can start that, and it looks like a Norton commander, new commander, or whatever commander you know. Actually, now that I think of it, we should do one other thing first. So I close that again. I'm going to the VirtualBox overview again. Here you have a button change settings for your virtual machine. This is what we are going to do now. The settings I'm going to change, you can only change when the virtual machine is running, so it's the correct time now. There's a shared folder symbol here. It's gemeinsame Ordner in German, but shared folder, it should be for you. And here you can set your own virtual shared folders. What I have done is actually I mounted 2 of my directories. This is more or less my home directory in the Apple Macintosh file system where I work if I want to transport stuff between my normal OS and the virtual machine. And what I also did on, at least on Macintosh, it is so that you can mount volumes, and I mounted the bare metal SD image, and I mounted it to, well, volumes bare metal. Volumes is the directory where all volumes are mounted with the OS X. And the name of my SD card is bare metal. So these are things you cannot change, and they are dependent on either the name of your SD card or the what operating system you are using where the files are mounted. What you can do now is add this plus. Plus is add a shared folder. What you do then, you choose what you want to import as a shared folder. And what I did was I imported this device. This is the bare metal device, the SD card actually. Then I clicked on automatic, and where I want to mount the volume. It would be good if you also put it into this name as I did. So /media/SD drive. This is what I call the path where the SD drive actually is mounted as a shared folder with a Ubuntu Linux system. Also permanent and automatic. Actually, what this does now, I already done it, so I can't press OK because the name is already taken. But this enables me to write to the SD card directly from the Linux system. So if I compile, I can, right after compiling, copy the new image to the SD card. Then I take out the SD card from my SD card reader, put it into the PiTrex, boot the machine up, and look what I have done. This is fairly easy, fairly straightforward going, and it's a matter of 5 seconds after compiling, switching the vectrex on and testing the image. Okay, you can or should do that. I will come back to that later when I show you how to compile actually. So within the file system, you logged in as a user Ubuntu, and your home directory then is home Ubuntu. This is your local home directory. The actual sources are already within the file system, the news sources from today. Well, if you watch this in a couple of months, then probably the files will be older, but anyway, this is what it's now. The files are located in the source directory, PiTrex software. And these are all the source directories that are available, where we have done work on emulators of different kinds. I'm not going into each of them because I already described some of them. I'm just going to explain the system. This is which we compile it with. There's a makefile within the software directory, makefile Baremetal. So now, excuse me, it's a little bit confusing, but I have not really planned this video, but I'm going to try. So now to actually compile, I haven't set up any scripts within the commander. I switch between the terminal and the commander depending on what I do. Now we have to open a terminal. With open terminal, right mouse button, open terminal, then a terminal window pops up, and there you can do your command line work. You're actually now in your home directory, so you have to change this to this path2. So cd source, cd PiTrex, and cd PiTrex again, and cd software. So now you see we are in the same directory. This is the makefile. To start the makefile, type make -f minus R. It's not a German keyboard, it's an English keyboard. You will know where all the signs are. Makefile bare metal. Minus F. Makefile bare metal. And now you can do a clean. You do not have to do a clean now because everything is clean. There are no files generated whatsoever. I can type make clean, but everything is clean. Now it's even cleaner. Then you can execute the top level makefile, and what this does is it goes through all these directories here and executes makefile or all makefiles within. This makefile actually looks like, I just pressed F3. This opens the viewer within the Crusader, in case you don't know. And this is a very basic makefile. It's just it got the C flags. It's nonsense. It doesn't use any flags. It only uses make all, and all the different make commands here jump into the subdirectory and execute a makefile there. So this is just a call of many makefiles, one for also to make them, and for clean just to call the appropriate makefile also with clean in the subdirectories. So this is not really magic. So let's just go, for example, to one of the makefiles because they all nearly look the same. I'm going to go any makefile. All these directories look the same. They've got a build directory, build bare metal. The makefile generates object files and intermediate files, sometimes assembler sources or ELF sources or whatever. They are all put into the appropriate directory in the build bare metal, and a clean will delete everything within there. I'm just going to open the makefile so I can show you the sections there. Don't worry, you do not really need this. I'm just explaining it. And to no real in-depth explanation, I won't do that either. So what each of these makefiles does is check all sources and libraries which it needs, builds them. So first it checks all the directories if they are correct, then it builds a PiTrex library. If it isn't built already, then it builds all the loader objects, and then this one actually creates the Vectrex video image. We are in the Vectrex video directory. This is the thing we actually want to create. So these are all the previous checks I just commented on, and these are actually the object files which are created for the Vectrex emulator. And then the image is built, consisting of all the libraries we had above here and the object file we generated here. And well, yes, it's GCC building a program. What it actually does is it builds object file with a file format which it thinks is for Linux. To be able to run it bare metal, you have to strip the file format. What you create is an ELF executable file format, and the object copy with these parameters removes the ELF part of the executable. So it doesn't only remove it in name but also in the binary, but yes. So then each makefile copies the generated image file. Such an image file is a bare metal executable file. You can actually boot with this file from the SD card. It copies it to the directory bare metal. So all of these files are collected in the directory bare metal, which is here, to bare metal. within this directory all of these files are now collected. So you can copy this whole directory to your SD card, and provided you have the other files needed for booting up, like this start elf and config blah and I don't know what, these are all files generated and startable then from the SD image. And what it further does, if you defined a global variable make image, then it also copies it directly to the SD drive. So what you have to do to create such a global variable, it's on the command line. You do it once per session, so to say. It's export. What was it called? Make image. You can paste. Make image like equals 1, or where's the equal sign on the English keyboard? There. So now if I compile any of these makefiles or execute any of these makefiles, the appropriate image files are also copied directly to the SD drive. This is what I usually do. I surrounded it with these if def protection mechanism in case you do not have the media SD drive facility, otherwise the copy command would always fail and the makefiles would fail. What you also saw here, the complete make process, all of these directories have now been processed and the makefiles executed, and you saw in the bare metal all the images were created. It's quite fast, I think, for all the images. It stopped at the end with a fail. It failed to compile asteroids, and that is because with this distribution I do not have the ROM files, or I did not include the actual ROM files. You have to put the appropriate ROM files within this asteroids SBT directory, and then it will generate the a binary translation file, and then it can compile asteroids correctly. The same goes for Tailgunner. Even if it would have processed asteroids, it would have failed for Tailgunner. For Tailgunner, the appropriate ROMs must be put into the directory, which I name soon, Cinematronics. Cinematronics, ROMs, and here within Tailgunner you have to put the ROMs. The compile mechanism then will also generate a static binary compile for Tailgunner, and only then the appropriate image file can be created. So what else is there to say? You saw that we use a GCC, especially for the ARM. I put the compiler into the directory in my home directory. This is where is it? It starts GCC ARM. This is a directory. I put it in there. This is not the newest GCC compiler. Actually, this is the newest GCC compiler, but I just tried it and it gave me some kind of stupid error message. I think some kind of library was missing some a name or some subroutine or whatever. I hate that. The GCC at the top is half a year older than this one, and they stupidly changed some elemental library so that the programs do not compile anymore. I was not in a spirit to look at whatever I had to change. It's probably only a very small thing I have to change, but anyway, I could not be bothered. I just took my old GCC, put it on here, and it works like a charm. And well, what is there? I want to build a bare metal. I don't care about any inner workings of GCC, if they have one bit better now than before. It's this is incompatibility. I'm annoyed. You might see that. So I think that actually was it. Now you can edit and compile bare metal programs. As said, I will not go into each of these programs. Perhaps what's interesting for you, if you want to change the menu code which I provided, there's a directory PiTrex boot. Within the PiTrex boot there's a loader main. Within this loader main, the configuration for the PiTrex menu is programmed. I open the file, F4 for edit. I actually use this editor to do editing. It's not an actual programmer's editor, but for my stuff it is enough. I can open files, I can open more than one file, I can search, I can replace, I can copy and paste. That is the most things I need. It has a little bit of syntax highlighting, which is good. Actually, I don't know what else it provides, if it has regular expressions or whatever. If you want to go to do serious programming, you probably want to install Vim or some other programming environment. I don't know. What do you know? The loader main. Yeah, this is the program which, the menu program, so to say. The program starts off at loader main and does here some setting up. Here it plays this wave file. This is PiTrex, which I say, and then it loads an YM file. This is a song that's playing in the background. This part here draws this PiTrex letters in 3D and rotates them. The menu gets initialized, and then we are in an endless loop which just displays the menu. And within this display menu, the selection for a menu entry is made, and from there it calls the load and start routine, and this actually loads another program and starts it. Well, that's what it's called, load and start. It loads another image file and then starts it. So this is how you start programs. And if you want to change the menu, you have to go to this display menu thing. It's quite at the bottom. This is the display menu. It first displays the current menu item, then it looks for joystick accesses, and if a button is pressed, it loads and starts the current menu item. Menu items are defined this is a menu item. It's a structure. Each menu item has an ID which is nearly not used, but it is used. It's a number which should be unique for each menu item. Then it's got a display name. In case of vector blade, this is vector blade, and a directory where it should load the image from. This is not used at the moment. This is the image file name. If you want to provide parameters to the file, to the image, you can do that. Actually, you can provide 4 parameters, but I never used 4. At maximum, I think I used 2, and only because I could. I could have put all that in 1 parameter. Anyways, you can define 2 parameters to pass to the image file with a maximum of 127 chars each. Then this is actually a vector list which displays an icon. The Vectrex and the arcade machine and such. This is the actual icon. And if you go further down, then this item shrinks, so to say. And if it's on the secondary stage, then the small icon is displayed. You can certainly put the same list to the two pointers, then the exact same icon will be displayed, but the second icon will be smaller because the size depends on the scale. It's automatically scaled down. But for the menu item, the large ones are much more detailed and they have quite a few vectors more, and I didn't want the display to wobble, so I scaled them down a bit and removed some of the vectors. Then these void pointers here are actually building up the menu tree, if you want to call it that. Each of them can be null. If it's null, then there's nothing present, and if it is not null, then it is expected to be another menu item. So if parent is defined, then you can actually go up and go to the to the parent item. The child item is the first item. When you move down, then, well, it's now self-explanatory. You can go left and then you can go right. And then you have an arbitrary number of text which is displayed with the menu item. Actually, I have not seen it wobble yet. I don't know how much text you can display. You have to test it out. I guess 4 lines is okay, 5 maybe, 6 probably not. And it depends also on the chars you use within the line. At the moment I'm using vector fonts, so if you need more text than a few vector words, then we could invent another flag to say it's a raster font or even a raster 5 font, each of which uses less cycles, so it does not wobble. So this is the structure of each menu item, and I thought about loading this data from disk with some sort of ini file. Perhaps I will do that someday, but as of now this does not happen. All the menu items are defined below here. These are actually the main items which are displayed at the top level. The first menu item is a Vectrex. It does not have any specialties. It only has the ID, the big Vectrex icon and the small Vectrex icon, and each of the other things have the same. Actually, now that I think of it, now I would do it differently. It doesn't matter. As you see, the left and right and up and downs are not defined here because I did not prototype the other menu items, which I later did. So there is a right now init menu function which sets the right and the left and the child menu entries. Well, you could do that differently or you don't, does not matter. And as you see, while I'm scrolling here, these are all the other menu items. Here I did prototype the next menu item, so I don't have to use an init function. Anyway, this is the actual menu item. For all Vectrex items, the ID starts with 100. For all arcade items, the ID starts with 200, and so on. So I have unique IDs, and the 100th digit shows which parent icon it belongs to. So this is the actual file that is loaded. It's always the image file. The next item is a Karl Quappe menu. The parent item is the Vectrex menu, and here you have the text section again by Malban. So there's not really much more to say about these menu items. If you want to add new ones, you have to copy and paste one of these, change them appropriately, and put the appropriate menu name within the previous menu and the next menu within your own menu item. So it's not complicated, it just looks perhaps complicated. Yeah, that's actually all there is to it. I'm not going through the code. I just want to show you, if in case you want to start or add special items which at the moment are not selectable at all with the current system. For example, the gyrox or something like that you cannot access, or any of the other emulators. I only came to up to Red Baron. I think I have not implemented all of them in the menu system. You can do that. It's left for the exercise for the developing programmer. Yes, I think that is all. And since this is not a camera I'm recording it with, but a tool on my Mac, I cannot show you the vectrex. So this is it. Go to a directory, edit a file, go to the directory with a command line, type make -f makefile baremetal. Then this image is generated, automatically copied to the baremetal directory here, and if you configure it right, it's automatically copied to the SD card you inserted, and then you can just rip the SD card out, put it in the PiTrex and start it. And you even can put it back after testing into your SD card reader. Since we configured it to mount automatically, after 1 or 2 seconds the SD drive is available again, and you can again continue prototyping, testing, whatever. Okay, I thank you, and I think this was all I was going to say. If there are any questions, here there should be a comment section. Thank you and goodbye.